Hey students, so welcome to math class. We are going to apply the knowledge that we have regarding about expressions and formulas, and we're going to learn about one particular formula: distance equals rate times time. Okay? So you will need your workbook pages 228 and 229. Let's actually go over what the formula means, right? So distance equals rate times 10, or D equals RT. Distance means how far. Some cue words that tell us that something is talking about distance include miles, kilometers, meters. Basically, think about like a plane or a car and how you would measure the amount of space or distance that it covers. Rate, R is rate of speed, basically telling you how fast is it. So when we're looking at rate of speed, usually it's written as mph, which stands for miles per hour. That tells you how fast a car can go. Or it could be obviously kilometers per hour. Usually they will tell you the per hour. So when you see that, that is your cue telling you that it's probably talking about rate, how fast something is. And T, time, that is probably the easiest to find. Time is how long, so how long something takes. Maybe it took 6 hours, 6 minutes, 6 seconds, right? So those are some of our buzzwords for time. Now, how do we solve word problems about distance, rate, and time? Here are the steps. Let's go over them together really quickly. Number 1, read the question carefully to find the unknowns. You're going to find the variable. Number 2, you're going to substitute the known information for the variables in the formula. Number 3, solve for the unknown variable. Number 4, label your answer. Okay, but this is so many steps and it sounds kind of confusing. You know what we should do? We should just solve it. That is how we learn, right? Okay, let's try this example. How many miles would a truck travel in 6 hours at an average speed of 55 miles per hour? Okay, let's unpack this a little bit. First step, well, we read it. Let's find the unknown. What is the unknown? Well, why don't we write down the formula first? The formula is D equals R times T. I'm just going to write RT here, but that's just the same thing, okay? It still means R times T. Okay, do we know the distance? No, because the question is asking for the distance. Do we know the time? Yes. The truck is traveling for how long? 6 hours. So I'm going to substitute T for 6. Do we know the average speed, the rate? Yes, 55 miles per hour. So I'm going to substitute the R with 55 miles per hour to find the distance. So we're just going to be doing 55 times 6, 330. And don't forget the unit. This is miles. Or you can just write MI, which is the short version. So how many miles can a truck travel in 6 hours if its speed is 55 miles per hour? 330 miles. That's your answer. Let's look at the second example. We're looking at here, okay? What is the average speed if a truck traveled 300 miles in 6 hours? Do you see how I'm underlining these keywords? This will help you figure out which ones are the known variables and which ones are the unknown. Okay, so what are we trying to find? What's the unknown? Average speed. So average speed is R, so we don't know R, we need to find R. Okay, then what's the distance? 330 miles, right? It traveled 330 miles, so we're going to substitute D with 330. R, we don't know, so just write R. What is the time? 6 hours. So our formula right now looks a little strange. I just switched the R and 6, okay? Now, this is where our expressions and our pre-algebra knowledge comes to play. What is the inverse operation of multiply by 6? Divide by 6, correct? What is 330 divided by 6? 55. Now, ladies and gentlemen, what is our unit? Well, it's speed. It's miles per hour. Okay? Miles per hour, mph. This is the speed of how fast this truck traveled. Okay? Now that we went over some of the examples, let's go ahead and dive into the exercises. Number 1. In 1929, a Zeppelin airship flew, okay, make sure to underline that, 11,247 kilometers from Germany to Japan in just under 102 hours. At what speed was it traveling? Okay, first question. What are we trying to find? Speed. Speed represents R. So we don't know R. What is the distance? How far did the airship travel? 11,247 miles. Good. So we're going to substitute the D. 11,247. Great. And what was the time? How long did it take? 102 hours. So we're going to substitute the T. 102. Now we have a formula. R times 102. What is the inverse operation of multiply by 102 divided by 102? Okay, so the R cancels out. We got to do 11,247 divided by 102. Long division, gotta love it, right? So we're going to kind of round the answer here, and it's gonna go up to about, so it's not exactly, about 110 kilometers per hour. So approximately 110 kilometers per hour. Number 3, if an airship flew for 52 hours at an average speed of 93 kilometers per hour, how many kilometers would it travel? So we're trying to find what? The distance, how many kilometers? What's the rate? How fast can it go? 93 kilometers per hour. So we're going to substitute. And what's the time? 52 hours. D equals 93 times 52, so 4,836 kilometers. How are you guys doing over there? Do you kind of see the pattern? Great. The Carson family drove at an average speed of 85 kilometers per hour for 4 hours. How many kilometers did they travel? So what do we not know? How many kilometers? So we don't know the distance. What's the rate? How fast can they go? 85 kilometers per hour. I understand there's a typo there. And what was the time? 4 hours. Okay? And 85 times 4 equals, well, I'll just tell you. 340 km, kilometers. Great. Let's move on. Austin's remote control car can travel at a speed of 22 yards per minute. How far could the car travel in 15 minutes? What is our unknown? If you see how far can something go, that's probably going to indicate the distance, right? How far can it go? Okay, let's substitute. What is the rate? 22 yards per minute. Another typo. What's the time? 15 minutes. 22 times 15 equals 330. And what is our unit, guys? Yards, right? Yards. That is another metric of measurement. So his remote control car will travel 330 yards in 15 minutes. Wow. Okay, we're going to do 8 together. Use your information from problem 7 to find how long it would take the remote control car to travel 1 mile if it continued at the same rate, same speed. Since this is an even number, I would actually like to challenge you guys to try number 8, and let's actually go over this during our Zoom session. Let's go to our next page. Okay, number 9. Complete the table. Find the number of hours that it will take to travel a distance of 1,500 miles at the indicated rate of speed. So let's back up a little bit. If you look here, it talks about the relationship of the number of miles traveled to the amount of time traveled. So miles and time, so distance and time. So we're basically going to be substituting the variables just like we were doing to complete this table. We're trying to find the distance of 1,500 miles. So if this is our formula, the distance will be consistent. It will not change. What will change? The rate will change. So it will be R times T. So for this one, the rate is 100. So we're going to substitute R with 100 and solve for T, which is time. The inverse operation of times 100 is divided by 100. So we're going to do 1,500 divided by 100. So T equals 1,500 divided by 100 equals what? 15. 15 hours. So you're going to fill it in like that. Okay, 200. Same thing, but instead the rate becomes 200 miles per hour instead of 100. So this time we're going to do divided by 200 like this, and 1,500 divided by 200 is 7.5 hours. Substitute R for 300 this time. Do you see the pattern here? So basically if you want to do the shortcut version, you're just dividing 1,500 with the rate. So 1,500 divided by 300 gives us the time because 300 cancels out. So this time T will equal 5 hours. So again, you're going to do 1,500 divided by 400 equals 3.75. 1,500 divided by 500, 3. 1,500 divided by 600, 2.5. Cool. Let me quickly explain how to do the next step. Number 10 says use the data from this table to complete the line graph. So we're just going to be plotting just like we did in our coordinate graph unit. So the bottom, it tells you the rate, so the miles per hour, these guys, and on the side you have the time, the ones we just calculated. So for this one, for example, the rate is 100, so find 100 here, go up to 15 hours, plot it. Do you see that? And rate 200, how many hours? 7.5. So right here you will plot it, and etc. And once you make all the plots, you're going to draw the line to complete the graph. Okay? And number 11, you just want to tell me what the general summary is. Does it increase, decrease, like that? So we are, again, like I said, we're going to go over this together during our Zoom just because it's a little more complicated. And yeah, otherwise, great job, and I will see you in English class.